Welcome to Robotics and Automation News webinars, where you can be part of a global event without leaving your home or office. Attend our live webinars and communicate directly with influential professionals in your industry.
Hello, my name is Abdul Montakim. I'm editor of robotics and automationnews.com. In this interview, I speak to Andrew Lonsberry, CEO at Path Robotics, which is a new startup that recently raised more than $50 million to commercialize its robotic welding work cell. According to some reports, hundreds of thousands of vacancies for welders will go unfilled in the next few years, and systems such as the one developed by Path Robotics may provide an answer to this serious recruitment problem. If the US is to reinvigorate the manufacturing base of the country, it needs solutions like the Path Robotics welding work cell in order to compete with countries where labor costs are much lower. Lonsberry, who did his PhD in the subject, says robotic welding uses machine learning and artificial intelligence and has the power to help the entire manufacturing sector to grow and become more efficient because approximately a third of all parts for machines require some sort of welding to be done.
I'm Andrew Lonsberry. I'm the co-founder and CEO of Path Robotics. My job as CEO is to really lead the long-term strategy and vision of the company.
I'm recording the website as we speak, so maybe I'll click around while you're talking. But yeah, give us an overview of your company, Path Robotics, please.
Okay, great. Path Robotics is an autonomous robotic welding company. We focus on creating solutions or creating intelligent robotic systems that utilize vision as their main input and driver to the system. We work on creating robotics that allow robots to learn, adapt, and make decisions on the fly. One of the huge value props to what we do is that there's no actual programming needed by the system. The system will completely program itself, basically off of what it's seeing in front of itself. We deploy this in a robots as a service methodology or go-to-market strategy. So what we're really trying to do here is reduce the risk of deployment for our customers and have our customers have zero capex at the beginning. So trying to reduce the barrier to entry for our customers wanting and needing to get into robotics by giving them a system that, again, doesn't have to be paid upfront in advance, but it can be paid on a subscription on a month-to-month basis. And again, all that goes into trying to make the system or trying to make our customers have as little risk as possible for deployment of new robotic systems. We really focus in on a couple different sizes of robotics. We focus on a smaller package, which we call the AW2, and a larger package, which we call the AW3. Here, as we see here on the website, the core competence of what the system does is it sees, and by see we mean it literally 3D scans the area in front of itself, and then if you scroll down, it says it understands, and what it does is it recognizes what should be welded, makes the decisions on the fly of how to weld that object based on whatever it is in front of itself. And then on the final piece, after it's looking and after it's understood what's in front of itself, it actually does the welding. And during the welding process, it's taking data while it's welding to give quality assurance analysis, but also to just be able to make small perturbations on the fly to ensure quality welding is happening at every single weld. And that is really the high level look of what we do at Path Robotics. If we want to scroll a little bit further, we can show the different sizes. So this is what our AW2 is. This is a little bit smaller footprint. And that's our AW3, which is a bigger mobile footprint. And so those are really our two product lines that we build.
Yeah, it's really interesting. I've got loads of questions spinning in my mind. The idea that something can code itself is fascinating. Well, I'll talk to you about that in a second, but just quickly, what kind of
Okay.
customers, applications do you currently have, or are you approaching with this solution? What typically is the customer? Are they automotive companies, or are they small parts makers? I don't know. I mean, I'm obviously not an expert, but yeah,
Yeah.
what kind of people are using or buying this system?
Yeah. So it's mainly customers that have a high mixture of part variety. So tier one automotive is not normally a customer that we would be going after. We'd be going after the tier two and tier three suppliers. So again, customers that really make a lot of different pieces, where they need something, or they would normally lean on the intelligence of a human welder to make the decisions on the fly of how to adapt based on what it's seeing in front of itself in terms of gap size changing, in terms of tax, or just in general doing an entirely new part. So that's the real market that we're kind of going after. So like small to medium sized markets, or small to medium sized customers. Again, customers that have a lot of change in their part variety, or a lot of part tolerance issues. As you can see on the screen, this is actually a larger part. It's like a semi-trailer chassis. A lot of welding goes down on something like that. And again, the variance from chassis to chassis is actually pretty significant. And this is where, again, something has to be able to make a decision on the fly to make a change. And running classic robotics on something like this can be really, really challenging. And so this is where that's kind of our sweet spot. So we support a lot of different industries. Tier two and tier three suppliers of automotive are definitely in our customer base, but there's all sorts of different customers that we're working with. People that are doing industrial ducting work, industrial electrical boxes, furniture. I would say the gamut on industries is really high. Oil and gas, construction, aerospace, kind of all around. But again, focusing more on customers that have high SKU counts and maybe lower volume. So somebody that's not going to do 100,000 of the exact same thing, but maybe 100 or 1,000 of the exact same thing.
Mm. Well, that's great. Thanks for that insight. Yeah, it's difficult to imagine from my point of view what kind of things are made and what kind of customers there. So I appreciate the insight. So let's explore the system
Yeah.
a bit more. The hardware. What is? I mean, obviously this code is supposedly writes itself or something, but yeah, what's the hardware then? Let's start with the
Yeah.
hardware. What hardware do you use as part of the overall solution? I know we had a look at the pictures down here. I mean, I'm talking about what make of robotic arm is it, or did you build that yourself, or did you just build the housing
Yeah.
or whatever it's called? So give us a rundown of the hardware, please.
Yeah. So the robotic arm itself is an off-the-shelf arm. In the pictures that you're seeing, these are Yasukawa arms, Motoman arms. We're robot agnostic though. So it could be ABB or Fanuc or Kuka, but specifically one of the big suppliers that we work with is Motoman. Same with the positioners. That's all Motoman robotic hardware. The big piece that we're adding is the vision system. So at the end of each robot, there's a little real-time feedback vision system, and then on the bigger AW2, at the end of that second robot is one of our larger 3D scanning systems. And so those are the two pieces that we add, and then we add really the brain to the system. So the system to be able to adjust on its own and think on its own, that's the big piece that we're adding. And most other hardware is kind of off the shelf.
Right, and when you say the brain, I mean, obviously the camera is there. Well, I can see it. Hopefully, some of the audience will be able to see it. It's a bit dark, but so where's the brain, as it were? Is the computer inside the camera, or in the robot somewhere, or in a PLC, or what?
Yeah, so you can't actually see the computer. There is a massive computer though that would be sitting kind of at the, if you were to go to the right, and you saw those little drawers.
Yeah.
Yeah, exactly. Yep.
So
So it's
they,
a big, big computer.
yeah. So what are these called? Are these called the PLCs, or they some other type of computing system, or what?
So on the rightmost side, that's like would be like our electrical panel that has our PLC, and then kind of on the ground there, we're just showing where our computer setup would actually be.
So these computers that you supply with the camera, or not?
Yep. Mhm.
Okay.
Oh yeah, we supply it with the cameras and stuff. We supply the entire this is the entire package is what we supply. The entire
Okay.
system is what we use as a subscription.
Right. Okay. Now, what if the client sometimes had their own PLC and computing devices that can do that part of the brain job? Can you install just the software on their hardware and run it like that?
No, unfortunately, no, it's kind of a one-time full package from us.
Right. All right, good. So give us a bit more of an explanation as to your sentence that no programming required. Let's watch the video while you do that. Let me see if I can switch the
Sure.
sound off while I.
Yeah, so we have two modes of operation, and specifically the mode of operation that this video is showing is a similar concept has been used before. It's called CAD to path. And so in this mode of operation, a user puts a part on, we just 3D scan the part that's in front of us. We utilize a CAD model coming from the customer that says, hey, this is the part I want to weld. On this part, I want to weld this seam and this weld size, and it's this material. When we do our 3D scan, we recognize the weldable seams on that object, and we run a registration process that would then overlap the CAD model to the real world model. And then we have the system program itself to avoid all the collisions possible in the scene and to perform the welding that is needed based on what that template was showing, basically. So that's the one mode of programming that that video is showing. So a very similar thing is called CAD to path. And I'm sure people maybe have heard of that before.
Yeah, it's obviously obvious questions are, does it need a bit of customization and adjustment to the specific job, or is it flawlessly recognizing everything that needs to be done and doing it flawlessly? How do you test that, and what's your experience of that?
Yeah, so I mean, that's really why we started this company, or why I started this company is the real world never matches a CAD world. The real world has a lot of changes. The gaps change continuously. The material dimensions really never match correctly. There's all sorts of, usually hidden collision objects with people adding clamps and whatnot to the workspace. And that's really the key point of Path, is to be able to account for all of those little issues, to be able to recognize what is a clamp, what is a part, to be able to recognize what is a weldable seam, what is not, what's the gap size of those weldable seams, and to be able to have the system, again, make changes on the fly to perform flawless welding, basically. So that's really what we push for, is a really robust system that can take into account all the imperfections that you see in the world. So we like to think that we do flawless welding. We like to think that we have a system that continues to, improve on its own and continues to be able to adjust based on what it's seeing in front of itself.
And what's the resolution of the image that is captured by the camera?
That's a good question. I am not exactly sure. It's metrology grade though, so you can see within fractions of a millimeter. You have like accuracy of at fractions of a millimeter.
And do you use different kinds of cameras for that particular function?
Yeah, so all the sensors that you see on the system, they're made in-house at Path. We have a group specifically focusing on building out our 3D capture systems, our 2D capture systems, really made to survive in the environments as well. Manufacturing environments usually have a ton of dust, have tons of different temperature ranges, can have higher humidities. You can see just this big range. And so specifically, we also make sure that the systems that are operating are built to survive in that environment.
Mm. So you make the sensors and the other bits and the camera itself. Do you make that? You design that and make that,
Yep.
yeah, okay, right. Well, it's a very sophisticated, complex system, and I have heard of robotic work cells before. Welding seems to be fairly new. Autonomous welding seems to be fairly new in the way that I'm seeing it. I know robots have welded cars together for many decades now, but I don't know if
Yep.
that's a different kind of thing. This is, I suppose, more complex welding. They're mainly welding rivets in automotive factories, aren't they? And other bits that are more like spot welding. I'm not an expert, but this seems
Yep.
a little bit more flexible and is able to make different parts and different kinds of things. So is this technology or is this system relatively new, or has it been around as long as industrial robotic arms? Probably not.
Oh no, this is very new. So this leans heavily on like a lot of machine learning and artificial intelligence that which was like the main focus of when I was doing my PhD research. We've only been around for a couple of years at this point as well, and we've only been launched for again like a couple of years. So I would say this is still relatively new into the marketplace. And as far as we know right now, we're kind of the only ones really focusing on this, truly fully adaptive, fully autonomous system. And then, yeah, like it was a great point. Tier 1 automotive has been utilizing welding robots for decades at this point. And again, it's more meant at those levels to just repeat the same, hand program a robot, watch it repeat the same thing hundreds of thousands of times. It's never looking at its environment. It's never making changes if a part moves or something. It would never be able to adapt to a new part on the fly. It's more of what we're trying to build is a system that's incredibly flexible based on what it's seeing in front of itself.
Hmm. Yeah, it'd be interesting to see how things go, and I'd be interested to see the kind of products it welds together. That obviously is a very good example. And this, what was it you called it? Something for a trailer? What's the object called?
It's like a semi-truck trailer chassis.
Trailer chassis. Okay.
Yep.
Yeah, so construct it's a big system if I can use those words. So, it can
Yep.
deal with objects that are large, and you mentioned construction and things like that. I'll ask you about construction. I mean, I read some article somewhere, and we published it on our site. Maybe it's a press release, but it was talking about construction as being fairly inefficient compared to other industries. Over time, it's used the same number of people. Productivity hasn't gone up, whereas other industries, all kinds of other
Yep.
industries, have reduced the number of people required and produced more. And that's because, according to
Yep.
him, whoever it was, he was saying that there's not much automation in construction. And I know this is, I suppose, a part which is then used by construction people to, so nothing in this sense maybe changes if you produce a part for construction. But
Yep.
what areas, I suppose I'm asking you, could be changed or benefited by this kind of system proliferating? If you're saying it's new, there's not that many systems around and it's flexible, can make lots of different parts and
Yep.
so on. If it catches on, how would it affect industry or manufacturing?
Yeah, I mean, so right now, the American Welding Society is estimating that there's going to be 400,000 human welder vacancies in the United States by 2024. And those like welder vacancies are normally going to be positions that really only a skilled human welder could operate in. So again, a role where somebody has to be intelligent enough to be able to make decisions on its own, whereas a robot, current industrial robots would not be able to make those changes. And I think that's really where we're trying to help, is help support the manufacturing industry, where you would normally need somebody as talented as a skilled human welder to be able to go in and again be able to make all adjustments on the fly to make something that's like structurally sound or hits the welding quality parameters that you're really looking at for. And so that's kind of that void that we're looking at specifically around construction. Where we see ourselves being helpful and useful is still in indoor manufacturing. So the suppliers to the outdoor construction industry. But you're totally right. The outdoor construction industry is one of those industries that really hasn't been able to change productivity for quite a long time due to the lack of being able to utilize potentially new systems or new automation. And again, it's such a difficult problem being outside, and you need people that are truly autonomous, that can make completely different decisions on the fly based on what they're seeing in the real world in real time. And robots just aren't at that point. And so we're trying to create a system that is at that point for a small subsection of the overall market, really focusing on the welding side, if that makes sense.
Yeah, it's very interesting to think about what comes to mind when you see this kind of work. I was thinking of prefabricated houses and buildings and ready-made or factory-made, as they call them. That's an area that, maybe hold some interest for you at some point. But yeah, tell us about what your business plan is. You're fairly new and you got a new system. How do you see things panning out over the next year or two for your business?
Yeah, so right now, we just closed a recent round of funding for 56 million. We as a company, we're growing very quickly right now. A big piece of what we're trying to do is continue to grow our headcount. We're currently around 100 people, looking to move closer to 160, 150 by the end of the year, really growing rapidly. We feel our customers are continuously trying to expand with everything that's happened with COVID. There has been a drastic need for hardening local supply chains currently, and a big piece of that is local manufacturing. And so we see a big pull from our customers needing help now on trying to get more systems into their facility. So we're really looking to utilize that new capital to continue to grow into our market pretty rapidly. And then by the end of the year, we'll be debuting our first new product outside of welding specific. And we're not really talking about it too much, but it's something that's going to be utilizing the same concept of having smart autonomous robots be able to make decisions on the fly and be able to adapt to the scenario that's in front of them to perform a manufacturing operation. And again, I think right now we're looking at deploying that before the end of the year. So that's kind of what we're seeing right now, and that's what we're kind of utilizing our funds for.
Yeah, it's a lot of money. Obviously, people believe in you. The total, as you mentioned, you've raised $56 million, and you announced it, nearly 2 weeks ago, I think, and we published it on our website. It brings according to your press release, it brings your total investment to $71 million, which is a huge amount. And obviously, these systems are not cheap to build from your point of view. You got all the robots to buy and lots of other systems and lots of people to pay as well. And so that from your point of view, it must have been a lot invested already. But that is that obviously puts a lot of emphasis on your. I don't know. Do you feel the pressure? I mean, what kind of targets are you having to think about achieving to I don't know if you need to make a profit for this money, but to justify the investment, if I can put it like that.
Yeah. So I mean, yeah, we are growing quickly. I don't really feel the pressure too much. 56 million was a number that we were looking to hit to actually help continue to grow at the pace that we're seeing right now. So feel really comfortable with it. We are obviously going after bigger numbers. If you raise 71 million, you got to be able to make more than 71 million. So yeah, we are, again, we're growing very, very quickly, and we're just feeling the market pull coming right now of more and more people really wanting this technology and needing this technology to improve and increase their throughput through their manufacturing facilities. So there are big numbers that we're targeting for sure, but these are big numbers that, again, in terms of our market size, aren't crazy. There's about $14 trillion spent a year on manufacturing in the United States. 50% of all man-made products have some sort of welding operation done on them. So the amount of manufacturing is just gigantic, and the amount of welding that is done is just massive. The market is very large, and so we're just trying to do our best to keep up with the demand from our customers right now.
It's a huge market even now. There's a lot of every time you hear stories about American manufacturing, it's always gives you a feeling that it's has been in decline a long time. It's not very big, but it's actually obviously America is still there or thereabouts the largest manufacturing nation in the world. I know China probably edges it a little bit in certain areas, but it is absolutely huge. And as you just mentioned, the numbers, it's a huge market to grow into. And I mean, best of luck with the how things are going. Yeah, we'll watch your progress. And I would I would say I would just wanted to ask you a little technical question before I go, which is when you say it recognizes or it can make decisions spontaneously or while it's working or in some way like that, you're probably talking about a fairly tiny set of parameters. So you can't, within which it can make changes and operate. But on a larger, higher level, this kind of, let's talk about innovation. This kind of innovation and robotics, some people say that it could level the playing field, whereas China and other countries have used cheap labor to compete. Well, obviously, robots and robotic systems are the same price for pretty much everyone around the world. Is that something that will make a difference to American manufacturing, or do you see it maintaining its current sort of trends and size, or maybe getting smaller? How do you see the American manufacturing sector, if you like?
Yeah, no, I think that's a great call out, and yeah, I think this is systems like ours and others that are coming. I think they're going to really help level the playing field in manufacturing locally for a lot of countries, and the United States being one of them for sure, where people can have access to robotic labor that really can perform kind of the job at hand, that can compete in terms of pricing and cost, and can really start to give people, and really start to kind of, again, level the playing field a little bit. So in our mind and from our perspective, we see technology like ours and again others really helping the U.S. manufacturing market and really strengthening it. We don't see it continuing to shrink. We would definitely see it continuing to go back in the other direction, where these systems and these tools will again kind of empower the ability to manufacture locally at a good price, but also have the flexibility that you would need to actually hit the potential demands that you would need. So from our perspective, we're going to see an increase in American manufacturing.
Interesting. That's yeah, I hope so, and I'm sure whatever happens, you'll do well. So yeah, all right. Well, thanks for your
Thanks.
time and your insights. Is there anything that I should have asked about that you would like to say?
No, I think that was great. I really, really appreciate your time as well. And thanks for walking through the website and through a couple of videos.
Send us an email at sales@roboticsandautomationnews.com to register for one of our many upcoming webinars. And if you'd like us to host your webinar, we have a range of options, including long-term lead generation packages and marketing campaigns. We look forward to hearing from you soon.